Question 11 is a transformations question. So it says, describe fully the single transformation which maps triangle T onto triangle Q. So this one onto this one here. So we can see we're trying to find out whether it's an enlargement, it's not enlargement, it's not a translation, it's not a reflection. So you can see it's a rotation, this one here. So you would need some tracing paper, and you would draw T on your tracing paper and then just try different things. So always start at 0, 0, and then turn it around your tracing paper to see when it would fit. And what you'll find is it will be a rotation of 90 degrees anti-clockwise, so it's going this direction to the left, about 0, 0. So this is the point where you'll be rotating your tracing paper. And then on the grid, draw the image of triangle T after a translation 2 minus 5. Now this just means 2 to the right and 5 down. So draw the image of triangle T after translation 2 to 5. So you take each point and you go 2 to the right and 5 down, and you put your point there. Take the next point, 2 to the right and 5 down, put your point there, and it's the same again for this last one. And you would just draw it, and that would be, I've just written T dash for that one. So question 12 is a relative frequency question. So it's a 6-sided dice is rolled 800 times. The table below shows the relative frequency of scoring a 6 after different numbers of rolls. So this one is building up here. So after 100 rolls, we get a relative frequency for 6 is 0.3, and we kind of keep building up on that one. So how many times was a 6 scored after 300 rolls? You can see the total here was 300, and the relative frequency for a 6 was 0.27. So for this one, you would just multiply those two together. 300 times 0.27, that's just like saying 27% of 300 as well. So you could work that out as 27 over 100 if you wanted to, and you would divide by 100, then times by 3. So this one is 81. So 81 times a 6 could possibly crop up 81 times if you roll the dice 300 times. So the next one is, which relative frequency from a table gives the best estimate of the probability of scoring a 6 when the dice is rolled? Explain your answer. So basically we've just picked 0.25, and that is because the bigger the sample size, the more reliable is the estimate. So the more trials you do, the more reliable it becomes. So how many 6s would you expect to get if a fair 6-sided dice was rolled 300 times? So because of the 300 times here is we put it down in here, and then basically a 1 over 6 is the probability of a fair 6-sided dice. So we do 300 divided by 6, which would be 50. Question 13 is an inequalities question, and it's asking you to solve it. Now I know that if I bring the 4n across here, I want to get all the n's on one side and all the numbers on the other. If I bring the 4n to the left hand side, I'm going to end up with a negative number here, negative n. So the best thing to do for this one would be to bring the minus n across to the right hand side and the numbers on the left. So first of all, I'm bringing the n across, so it'll be 4n plus n would be on the right hand side because I'm moving this minus n across, which changes to a plus n. Then I'm moving the minus 3 across to this side, which will then change to a plus. So 12 plus 3 is greater than 4n plus n. So 4n plus n is 5n, and 12 plus 3 is 15. So this one here is just going to be 15 divided by 5, which is 3, and 3 is greater than n, but then if we change it around to have n on the left hand side, we have to change, the sign is pointing to the n, so when we kind of flip it around, it should still be pointing to the n, which we have here. N is less than 3, and that's the final answer for that one. So question 14 says, John has 6 shirts, 8 ties, and 5 cravats. John is going out to dinner. He must choose a shirt and either a tie or a cravat to wear. So how many different combinations has John got to choose? So the combinations I have, you can do it in slightly different ways of doing this, but I've done it this way. So it's shirt, this is a combination, so it's shirt and tie, and shirt and cravat, and that's the or. Shirt and tie or shirt and cravat. So in probability, if you've got an and, you are times them together, and if you've got an or, you're adding. So 6 times 8 is 48, 6 times 5 is 30, and then we have 78. So that just means there's 78 different combinations John can choose from. So question 15 is an index question. So it says 3 to the power of 0 plus 4 to the power of 0. Now anything to the power of 0 is 1. So that 3 to the power of 0 will be 1, and 4 to the power of 0 will be 1. So that it ends up being 1 plus 1, which is equal to 2. And that's the answer for that one. This one here is 2 to the power of minus 3. So if you see a minus, an index that's got a minus there, you want to make that positive. And the way you would do that is by putting 1 over 2 to the power of 3. So you can see that the index is positive just by putting 1 over that number. So then we've got 2 to the power of 3 is 2 times 2 times 2 is 1 over 8. So question 16, it's a standard form question. So it says a 1 gram bag seed contains 500,000 seeds. If each seed weighs the same, calculate the weight in grams of one seed. Give your answer in standard form. So that's one seed out of 500,000 seeds. So the way you would write that is 1 out of the 500,000. Now to change 1 into a standard form, it's just 1 times 10 to the power of 0, because 10 to the power of 0 would just be 1. Anything to the power of 0 is 1. So 1 times 1 is 1. So that just gives you the value of 1, but it's in standard form. Then you've got 500,000, which then gets changed to 5 times 10 to the power of 5, because you can see there's 5, the point would be here, and there's 5 numbers after that. So 1, 2, 3, 4, 5. So 5 times 10 to the power of 5. Next, we do 1 divided by 5, so which is here, and then we do 10 to the power of 0 divided by 10 to the power of 5. So that when we're dividing, we take away our indices. So that'll be 0 take away 5, which is minus 5. So we've got 1/5. 1/5 is 0.2 as a decimal. So 0.2 times 10 to the minus 5. And then, okay, this is one way of doing it. You can put it into the full number. If it's small enough like that, then you can change it to standard form. So if we put the point at 2, just after the 2, it's going to be 1, 2, 3, 4, 5, 6. So it's going to be 2 times 10 to the power of minus 6. So question 17, it says, when Jan goes to the gym, the probability she wears a tracksuit is 3 out of 4. When Tina goes to the gym, the probability she wears a tracksuit is 2 out of 3. So complete the tree diagram. So we can see that when Jan wears a tracksuit, a probability is 3 out of 4. So these two probabilities should add up to 1. So what we have here is 1 out of 4. So that if we add these two up, it will be 4 out of 4. And that would equal 1. So that's what we've got here. And the other part of the tree is Tina. And it basically says 2 out of 3 for this one, if she wears a tracksuit. So Not wearing a tracksuit would be 1 out of 3 because both of these should add up to 1. And that should be the same as well. And that's basically what you have to do to fill in that tree diagram.